We're going to be looking at the math today to help us design our parabolic reflector. Here's an image of something that we're going to be trying to build. You can see it's a reflector that captures the sunlight and uses it to focus onto this pot. So we're going to do the math for that. The first thing we're going to do is make a sketch of what we want our parabola to roughly look like. So here's my parabolic shape. Now, just so that everyone knows, we have sunlight coming in from above or from this direction, and the properties of the parabola mean that all reflected light, when it comes off the reflector, it all heads towards a central point. That's the focus. We're going to figure out in the next video where the focus is, but right now we're just going to figure out the equation for the parabola that we're going to use. We need to know the width of the parabola, and we also need to know the depth of the parabola, and that's going to be different for everyone. So for my parabola, I want the width to be around about 2 feet wide, which is around about 60 centimeters. And the height, since we're working in centimeters, I want to be around about 15 centimeters high. Okay, 60 centimeters means that I'm going 30 centimeters each way from the origin. So my parabola will have roots at -30 and +30 with the y-axis there. And the y value here is going to be about -15. That's where this point is on the y-axis. So I want a parabola that has these properties, and so I'm going to go to Desmos to try and figure that out. Well, I know my roots are at -30 and +30. I also know that this is the factored form for a parabola that has roots at those points, x plus 30, x minus 30. But if I zoom out, you can see that my parabola is really steep. It goes down to almost -1000. So obviously I'm going to have to modify that quite significantly to get the 15 centimeters height that I'm going to want. So I can start by trying -0.1, still too deep, 0.01, a little bit too shallow, 0.02, getting close. At this point here I am -18 centimeters, -16.2, 15.3. To me, that's close enough. So this is my equation, 0.017 times x plus 30, x minus 30. Okay, let's go back to my sheet and see what I've got over here. So I have 0.017 x plus 30, x minus 30. Good. That foils out. If we kind of ignore the 0.017 for a minute, I'll still write it, but let's have a look at what this foils out at. I have the first term gives me my x squared. My outer term is minus 30x. My inner term is plus 30x. Hopefully you can see the beauty of doing it this way. Those outer and inner terms cancel. And then the last term is plus 30 multiplied by minus 30, give me -900. Okay, distribute the 0.017, 0.017x squared. If you can't see immediately what 0.017 times 900 is, don't worry. We can go back to Desmos, a new line, 0.017 multiplied by 900, of course, is 15.3. No surprise really that it's the 15.3 from the vertex of my parabola. Minus 15.3. And that's the equation that I'm going to use to describe the parabola for my parabolic bowl. In the next video, I'll show you how to figure out how high the focus is from the origin, and also how high it is from the very bottom of the parabola. But that's enough for this video.